Good morning, dear students. How are you? Hopefully, everyone must be fine, right? During this lockdown and pandemic, corona pandemic, right? So, I hope everyone is fine and well, and they are doing well as well in their studies. Yes or no, right? So, today we are going to just a minute. Yes. So today we are going to discuss the last part of our motion, that is the fifth session, right? Just I'll quickly recap what we discussed so far. Okay. So in this motion series, what we discussed so far, in the first session, we discussed some introductory parts, right? We discussed about distance and displacement. These are the two main parameters we discussed, right? So distance is what? Yes, it's the distance covered by the object or the path covered by the object, right? Whatever the length you measure of the path, no matter what direction you follow, right? Direction does not matter for the distance, but what matters? Displacement. For displacement, direction matters, है ना? Displacement के लिए direction की जरूरत होती है, because displacement क्या है? Scalar vector, right? It's a vector. और distance क्या है? It's a scalar, isn't it? तो डिस्प्लेसमेंट हमने क्या डिस्कस किया? डिस्प्लेसमेंट इज द शॉर्टेस्ट डिस्टेंस कवर्ड. डिस्प्लेसमेंट इज द शॉर्टेस्ट डिस्टेंस कवर्ड बाय द ऑब्जेक्ट, right? And direction do matter for displacement, but for distance it does not matter, right? That's what we discussed in the first session. Then in the second session we had discussed about the rectilinear motion. If you remember, rectilinear, linear means along the one single line or along one single path. That's what it means, rectilinear, right? Or in other words, we can say it as one-dimensional motion. Exactly, right? One-dimensional motion or 1D, right? 1D motion. When you study further, 10th standard, 11th standard, 12th standard, it comes 2D, then it comes 3D, like that, right? So that's how it comes. 2D, 3D. We will discuss that further in the further sessions. So, but in the second session of motion series, we discussed about one-dimensional motion or rectilinear motion. Apart from that, we also discussed scalar and vector, right? So scalar क्या quantity है? जिसको magnitude और direction की जरूरत होती है क्या? No, scalar is that quantity which requires only and only magnitude. Direction की कुछ जरूरत नहीं होती. इसके लिए हमने example discuss किया mass, right? Mass is a scalar. When I ask you what is your mass, you don't mention your direction. You don't say my mass is 50 kg in not direction. My mass is 60 kg in is direction or is direction, so and so forth, right? So mass is a scalar quantity. तो जो quantity जिसको सिर्फ magnitude की जरूरत होती है, उसको हम क्या बोलते हैं? Scalar. Exactly. Very good. Then we discussed vector. What is vector? Vector मतलब ऐसी physical quantity जिसको direction as well as magnitude दोनों की जरूरत होती है. Example we discussed velocity, right? Velocity or displacement as well. Just now I discussed. Displacement requires direction and magnitude both together, right? That's what we discussed in the second session. Then in the third session, we discussed about graphs, right? So far we learned about distance, displacement, scalar and vector. Okay, fine, no problem. But how do you represent that? कैसे represent करना है उसको graph के terms में, right? So coordinate geometry का basics discussion किया हमने. X-axis, Y-axis, that's origin, right? Represent the coordinates. Every point has coordinates, x and y coordinate, right? X coordinate, y coordinate. You point them or you plot the graph. Graph sheet is there, right? Green color का graph sheet मिलता है market में. You might be aware about that, and you must have used. I'm damn sure, right? तो वो graph का representation हमने किया one-dimensional motion का, and then we discussed few numericals on that as well, right? That's what we discussed in third session. Then in the fourth session, we discussed very important part of the foundation of mechanics, right? 3 equations of motion, right? Anybody would like to tell? Those who are on the chat. Okay. So till now, I think one or two students have joined. Anyways, so 3 equations of motion we discussed. First equation was V equal to U plus AT. That's the first equation. Second equation, S is equal to UT plus half AT square. And the third equation, V square equal to U square plus 2AS. That's what we discussed, right? So these are the 3 main basic equations we discussed. And these are very, very important equations. And my request to everyone is please remember these equations. How do you apply that? That also you have to remember, right? और उसके ऊपर हमने न्यूमेरिकल्स भी डिस्कस किए, right? Exactly. So those who have missed my previous sessions, I request everyone again to please go through the previous sessions on our Swiflearn channel, right? Again, I welcome everyone on our Swiflearn platform, right? So let us start about today's session. So today's session, what to discuss? Yes, uniform circular motion. Exactly. We are going to discuss about uniform circular motion. Okay, let me share the screen with everyone now. Okay. So hope the screen is visible to everyone. And my voice is also continuous and audible as well. Okay. Fine. So here we are, the Swiflearn, team of Swiflearn. Here we are for your help in all your successful career, right? So we are India's most sincere learning destination from class 3 to 10. Why? Because of these main four features. First is we are 100% live right now, and I'm giving you the online session, right? Right now you can ask me doubts on the chat, right? I'm available for you right now. It's just 100% live and interactive classes, right? We are able to interact with each other to the chat session, right? So this is the first specialty of ours. Second is personalized attention, and we have a maximum of how much? Only 6 students, right? Why 6 students? Because we can give personal attention to each and every student. क्योंकि जितने ज्यादा स्टूडेंट होते हैं टीचर को बहुत मुश्किल होता है ना, हर एक स्टूडेंट के पास के या फिर हर एक स्टूडेंट का पर्सनल, it's quite difficult, isn't it? So we have kept the maximum limit of how much? Only 6 students. That's a specialty of us. Second specialty. Third specialty, mentor team for your all progress, right? Academic progress. Exactly. Of course, character wise as well, right? So that also we do, right? So first is we have academic mentor team to track and work on student progress. How far you have gone or traveled, how far you have to travel to achieve your success, right? So that's, we have a team, dedicated team for that to tackle your progress. कितना आप आगे बढ़े हैं और कितना आपको और आगे बढ़ना है, right? And the fourth and very important, that is we cover all syllabus. Whatever syllabus is given to you as per your ICSC board or CBSC board, we conduct all the topics from top to bottom, everything. And also at the same time, we accept the custom requests. Like, some students have some exam, unit exam or midterm exam, and they want to, undergo practice tests. So we also accept those requests and conduct a special practice tests or even doubt session as well for you, especially for you, right? So these are the main four features what we are providing you for your own successful career, right? So please do take benefit of this. Don't miss any of these benefits, right? There are further few features we have. That is detailed progress reports. As I mentioned, we have a team to check out your progress, and we have detailed progress reports. We provide that. At the same time, we have SATs. What is the SATs? It's Swiflearn Academic Test Series. And also we have practice tests. We strongly believe on this. Practice makes man perfect, right? तो हम जितना ज्यादा हो सके बच्चों के साथ प्रैक्टिस करवा के लेते हैं एग्जाम्स का, right? Test series we conduct, practice tests we conduct, right? Regularly, weekly basis, everyday basis, whatever, how much ever you want, And lastly, we also conduct subjective tests for school exams. That is this one, right? So subjective tests are also there in your schools, unit test, right? Midterm tests and so on and so forth. We also conduct those subjective tests, right? So why wait? Please book a free trial class, right? And at the same time, I want to add here one more thing. We are also conducting crash courses, right? Now your exams are approaching, right? The year end is about to finish. This is the last month, and next year in the beginning, your exams will start in the February or March or April, something like that. So most of the students want to revise all the syllabus, right? So we do conduct a crash courses for your all academic sessions, right? What the topics are there for your entire session, right? Entire academic year, we cover, right? All that in the crash course. Quick revision, that's what we call, right? Right. So we also conduct that, and I want you to take advantage of that as well. Okay. Fine. Before I go ahead, if you have not yet subscribed to our channel, please do subscribe and don't forget to press a bell icon so that you don't miss any of our live updates, right? Okay, so should we start then? Okay, fine. Everyone is ready? Let's start today's session. चलो चालू करते हैं आज का सेशन. Motion fifth, part fifth. Uniform circular motion. That's the main thing we are going to discuss here. UCM. That's what we call it, right? So क्या हम डिस्कस करेंगे आज? ये चार मेन टॉपिक्स डिस्कस करेंगे. पहला वाला यूनिफॉर्म सर्कुलर मोशन UCM. Second is activity describing uniform motion, right? Third is centripetal and centrifugal force, right? And fourth is numericals based on uniform circular motion. So these are the main four paradigms we are going to discuss today, right? Basically uniform circular motion, uniform circulation होते समय कौन से forces लगते हैं, that is centripetal and centrifugal force, और इसके ऊपर हम कुछ numericals discuss करेंगे at the end of the session. Okay, so here we go with the first. As you have studied that when the velocity of an object changes with time, the motion of the object is said to be accelerated. Remember, we discussed this about accelerated, right, motion, or acceleration and deceleration, right? We discussed that in the second session, acceleration and speed and displacement, velocity, we discussed that, right? So acceleration मतलब क्या? For the vehicle you have the accelerator, है ना? अब accelerator घुमाते तो क्या होता है? गाड़ी का स्पीड बढ़ता है, right? धीरे-धीरे बढ़ते जाता है गाड़ी का स्पीड, and it reaches to its maximum, right? तो accelerated motion मतलब जिसमें velocity बढ़ती है, समय के साथ velocity बढ़ती है और speed बढ़ता है, किसका? vehicle का, उसको बोलते हैं accelerator. कार के लिए होता है, कार के लिए भी पैर में होता है, देखिए ब्रेक के टैब के बाजू में, you have this accelerator, right, at the down bottom portion of the car. Beside the accelerator there is a brake as well, right? तो accelerator को आप प्रेस करेंगे तो क्या होता है? गाड़ी का स्पीड बढ़ता है. So what it says here, the motion of the object is said to be accelerated. जब कब होगा ये? जब velocity changes or increases with the time. To be very specific, अगर velocity बढ़ रही है, speed बढ़ रहा है समय के साथ, तो क्या होगा? Body से accelerated motion, right? So as velocity is a vector quantity, right? Vector means जिसको magnitude और direction दोनों की जरूरत होती है. Magnitude as well as direction, right? That means it has both magnitude and direction. Therefore, velocity can be changed by changing three parameters. Now velocity हम change कर सकते हैं by changing its magnitude. That is, let's say magnitude is now, let's say it is 10 km/h, but I want to change it to 20, then to 30, then to 40, 50, like that, so on and so forth, right? So by changing the magnitude, first thing. Second thing is by changing direction. Direction change करके भी आप velocity change पे हैं. Velocity vector है, इसको magnitude और direction, either I change the magnitude or second direction. Thirdly, by changing direction as well as magnitude, दोनों भी change कर सकते हैं. Direction भी, दिशा भी change कीजिए और उसका magnitude भी change कीजिए, right? So these are the three ways of changing your velocity, right? By changing magnitude, by changing direction. The third one, very important, both by changing direction as well as magnitude. That's how you can get your vehicle accelerated, right? Further, velocity can be changed by changing magnitude, by changing direction, and by changing both, right? So can you think of some examples here? Yes, anybody on the chat would like to tell me some examples where you can velocity, both its magnitude as well as direction, right? Simple example I can recollect is your vehicle. When you are driving a vehicle, right? Let's say you are passing from a city to highway, right? As soon as there are no more vehicles much, right? जैसे crowd होता है city में, market में, उतना crowd highway पे नहीं होता है. तो city में आप drive करते हैं crowd में, market में drive करते हैं, तो आपका speed बहुत कम रहता है, right? You should drive very slowly because there is a traffic and people are walking here and there. There are people here and there. That's why you drive little slow in the city when you drive in the market. मगर आप जैसे highway reach करते हैं, what happens, right? There are not much vehicles compared to the market, right? तो क्या करते हैं आप? You increase the speed, right? By accelerating. If you are driving automobile, accelerate, or if you are driving by a car, you press accelerator, तो हम speed बढ़ाते हैं और direction भी change कर सकते हैं, right? Because highway has directions left, right, straight, right? So by changing both direction as well as magnitude, you can change the velocity, right? So here are a few examples you can see here. The first example of what it says here is in a rectangular path, speed is constant, but the direction is changing at every point, that is at 4 corners, right? As you can see this, in this diagram, there are 4 corners. It's because it's a square. And let's say you're traveling on a border or perimeter of this square. ठीक है ना? आप ये square के sides के ऊपर walking कर रहे हैं, right? So let's say you are here, right? Then you go straight. Once you travel this much distance, then you have to take left, right? Because that is what the path of the square. Then after crossing this distance, then you have to come down, right? That is towards south, right? And then after covering this much distance, then you have to cover, yes, east direction, right? Again, after covering this east direction, then again you have to take north, right? So every time you are changing your direction, right? After covering some definite distance. Now this distance is, let's say, 1 meter or 2 meter or a few kilometers, whatever it is, right? So if this is side of the square is, let's say, 2 meter. So every 2 meter you are changing your direction. Are you getting this? But speed can be same or can be different, depends upon you, right? Right. So at what points this direction is changed? First, second, third, and fourth. So in one revolution, you are changing your direction how many times? 4 times. Is that clear? Example, fine. Second, if a ball is dropped from a height, the speed of the ball will increase, but the direction will remain the same. That is downwards, right? Simple example I can tell you here again. Let's say this is a pen, I'm dropping it, right? When I'm dropping it, what is happening with the direction? Direction is same or changing? Direction is same. It is falling down, right? So direction is same. Direction is same. But what about the speed, sir? Speed के साथ क्या हो रहा है? Speed is increasing or decreasing? देखो यहाँ पर तो stationary था starting में, और जैसे मैंने छोड़ दिया उसका speed बढ़ते जाएगा. Because it is acting under gravity. Exactly. Gravity force होने के कारण क्या होता है? ये आपका जो पेन जो आप fall it is called as free fall basically. Free fall होने के कारण क्या होता है? Yes, because it is acting under gravity, क्या होता है? The speed is increasing as the time passes. As soon as it reaches ground, then speed will decrease. Right? It hits the ground, and speed will decrease like that. That is your second example. So first example में direction change हुआ, speed के बारे में कुछ पता नहीं. Speed I can change or can be constant. Second example में क्या discuss किया हमने? Direction is same, but speed is changing, or I can say to be very specific, increasing. And the third example, as you can see here, if a ball is hit on the wall, then there is a change in the speed as well as direction. Now you must have played this game, playing with the ball against the wall, right? Especially in pandemic, right? It's quite difficult for those who are, very much fond of playing in the outdoors, right? So you must have not restricted or controlled yourself when you must have played in one particular room in your home, isn't it? So take a ball and hit against the wall. Then as soon as you take a ball and hit against the wall, right? What happens? The direction changed. Direction as well as velocity is also changed, or speed is also changed. Because before hitting this ball to the wall, its speed is more. As soon as it hits the wall, its speed decreases. But after hitting the wall, it is falling down. That means its speed is under gravity. तो उस समय आपका speed क्या होगा? बढ़ेगा, right? तो देखो third example में direction भी change हो रही है और speed भी change हो रहा है. Are you getting this? All these 3 examples are clear, very clear, right? So third example is the most important, in which I am changing both direction as well as magnitude. दोनों change हो रहा है यहाँ पर, direction as well as magnitude. Is that clear? Fine. So let us go ahead. Now let's consider an example of the motion of an object along a closed path. Suppose an athlete is running on a rectangular track, let's say ABCD at a uniform speed, right? So let's say there is an athlete. You must have taken part in athlete as well, running competition in your school, right? So yeah, let's say you are an athlete now, and you have to travel from a path of A, B, C, D, and coming back to A, B. Okay, because it's a repetitive motion. So let's say you start from A. Sorry, let's say you start from A. A से चालू किया आपने, right? A से चालू करने के बाद कहाँ पर गए आप? B के बाद किया सी पे जाने के बाद डायरेक्शन चेंज किया, वापस डी पे गए, डी पे जाने के बाद वापस डायरेक्शन चेंज किया, ए पे आ गए वापस. सो दिस इज ABCD, isn't it? It is in which sense? Clockwise, anti-clockwise, right? Anti-clockwise, correct? So athlete is running on the rectangular track. Let's say A, B, C, D. Athlete is running, right? So how many times an athlete has to change the direction, right? How many times? 4 times. Athlete has to change its direction how many times? 4 times, right? To complete one revolution or to complete one single track on the rectangular path, right? So here, how many times it has to change the direction? 4 times, right? 4 बार उसको क्या करना पड़ेगा? Direction change करना पड़ेगा. Athlete, right? Now let's say instead of rectangle, if I take, what is this? Hexagon, exactly. Hexagon hai, right? A to B, B to C, C to D, D to E, E to F, and then again F to A back, coming back to the initial point, right? कितनी बार direction change करना पड़ा बताइए? Now suppose the athlete is running along a hexagonal shape path. How many times the athlete will change the direction of motion in order to complete the hexagonal path? बताइए, how many times? Right? Let's say if I start from A, right? A से start किया मैंने, right? Then as soon as I reach B, I have to change the direction. As soon as I see, I have to change the direction. As soon as I reach D, change the direction. As soon as I reach E, again change the direction. As soon as I reach F, again change the direction. As soon as I reach A, again I have to change the direction. Right? So how many times? 1, 2, 3, 4, 5, 6. How many times? 6 times you have to change the direction because hexagon has how many sides? 6 sides. 6 sides है इसलिए 6 बार आपको direction change करनी पड़ेगी. Earlier case, rectangle was there. How many sides rectangle has? 4 sides. तो 4 बार आपको direction change करनी, right? But here it is 6 times. Now let us move further, right? 8 times. This is octagon, right? Now suppose the athlete is running along an octagon path, octagonal shape of path. Then how many times the athlete will change the direction of motion in order to complete the hexagonal shaped path once, right? If you have to cover this perimeter of an octagon, then how many times you have to change the direction in one revolution, right? So let's say you start from A, then you once you reach B, change direction, C, change direction, D, change direction, E, change direction, so on and so forth. You proceed, and you come back to A. How many times you have to change? How many sides octagon has? 8 sides, is it not? So how many times you have to change the direction? 8 times. Are you getting this? So 8 times you have to change the direction if you have to complete one revolution. And in 2 revolutions, can anybody? 2 revolutions, 16 times. 3 revolutions, 8 into 3, 24. 4 revolutions, 8 into 4, 32. So on and so forth. It will keep on increasing, right? So as you keep on revolving around this hexagon, right? What is happening? You're changing your direction, right? In one revolution, 8 times. As many revolutions you take, that many times you have to change the direction. Is that clear? Right? समझ में आ रहा है बच्चों? Hopefully, yes. Fine. Let us go ahead. So these three all examples are together. I'm placing it. First case we discussed about rectangle. Second case we discussed about hexagon. And third case we discussed about octagon. Right? As the number of sides of the triangle increases, the athlete has to take turns more frequently. Right? Now instead of octagon, if I take 12 sides, then how many times you have to change the direction? 12 times. Right? If there is the sides are there, it's 16. So how many times you have to change the direction? 16 times. Are you able to understand this? Right? So जितने आपके sides रहेंगे ट्रैक के, उतनी बार आपको आपकी दिशा चेंज करनी पड़ेगी, right? So depends on the path and the directions, or here specifically I can say the sides of a particular shape of the path. Is that clear, everyone? Fine. चलो आगे बढ़ते हैं. If the number of sides keeps on increasing, the track will take the shape of the circle, and for this case too, the change in direction is responsible for the change in velocity. Now let us discuss very interesting example. Circle is there, right? And you have to go around this circle, right? So let's say you start from here. यहाँ से चालू किया, A से चालू किया, है ना? A से चालू करेंगे तो क्या होगा? You have to complete revolution. So now see, let me take the pointer. Just give me a minute. Fine. Let's say you start from here, okay? A से चालू किया. Let me change the color as well so that you can understand. कौन सा कलर ले? चलो रेड कलर लेते हैं. Let's say आपने यहाँ से चालू किया A पॉइंट से. B पॉइंट पे जाने के बाद डायरेक्शन चेंज करना पड़ेगा क्योंकि A पे आपकी वेलोसिटी वर्टिकल है, B पे देखो ऐसी है, राइट? मान लीजिए C पे गए आप, तो अगेन यू हैव टू चेंज द डायरेक्शन एज वेल एज स्पीड. अगेन D पे आ गए आप, again you have to change the direction. If you come at E, again you have to change the direction. If you come at F, next process, again you have to change the direction. If you come at G, again you have to change the direction. Right? Are you getting this? Again, if you come at H, again you have to change the direction. So at every moment, every point, your direction is changed. Are you able to understand this? Right? So the motion along the circular path is therefore an example of accelerated motion. Because at every point, you see this, how many points I have mentioned here? A, B, C, D, E, F, G, H, right? So at every point, you have to change the direction. And as I shown here, direction with the arrow. But direction भी change करनी पड़ रही है आपको और speed भी change करना पड़ेगा. We're getting this. So this motion is which motion? Accelerated motion. What is accelerated motion? Accelerated motion मतलब जहाँ पर आपकी speed change हो रही है समय के साथ. The speed is changing with respect to time. That is what is called as accelerated motion. Is that clear? Anybody has any doubt so far? Anybody has any doubt? Fine. No problem. So let us go ahead. Let me clear this all. Fine. Now, we need to calculate speed. What's the formula for speed? It's a distance traveled by time, right? And velocity क्या होता है? Displacement upon time, isn't it? So speed is equal to distance traveled divided by time taken. So suppose an athlete completes one round of a circular path. कितना? One round उसने complete किया, athlete. Of radius how much? R. R is the radius. Radius circle का radius R होता है, right? In how much time? T seconds. Then the speed is. Speed you have to calculate. Distance traveled is equal to circumference of the circle. Now देखो distance कितना travel किया? Say you are traveling on this circular path, right? So when you are traveling on the circular path, what is happening? You are completing one revolution. So in one revolution, how much distance is traveled? Let's say the radius of the circle is R. So you start from here and you complete one revolution. So in one revolution, how much distance you have covered? Equal to circumference of the circle, isn't it? And what is the circumference of the circle? That is 2 pi r, right? 2 pi r is the circumference of the circle. So distance traveled would be 2 pi r and time taken would be t seconds, right? So what's the formula for speed then? Yes, 2 pi r upon t. That's what the formula for speed. So speed is equal to distance traveled divided by time taken. This formula you have to remember, okay? Everyone, right? So distance traveled is how much in one revolution? 2 pi r. And what is the time taken? That is t seconds. So r की जगह आपका हो सकता है 1 meter, 2 meter, 3 meter, whatever the calculations, you can do that, right? Let's say it is 1 meter. So 2 pi into 1, that comes out to be 2 pi. And time taken is, let's say, 5 seconds, right? 1 meter circumference is covered, right? A 1 meter radius circumference of this circle is covered. In how much time? 1 second. So 2 pi meter per second. That's what the answer. That's what the speed of yours. If the circle radius is how much? 1 meter, and you are covering in 1 second. Let's say you are covering in 4 seconds. So 2 pi by 4, right? 2 pi by 4 is how much? Pi by 2. Are you getting this? So as the values of r and t changes, your speed keeps on changing depending upon r and t, right? R is the radius and t is the time in second. Is that clear? Fine. आगे बढ़ूं मैं? Okay, fine. Now let us discuss very important part of today's session, that is called as uniform circular motion. Shortly we call it this as UCM, right? Uniform circular motion. अब uniform circular motion क्या होता है? Okay, let us start with a practical example. Any practical example for UCM? Anybody? Uniform circular motion, बताइए जल्दी. You must have seen that, right? Especially I will give the hint in the summer season in the home. समर सीजन में सबको बहुत गर्मी होती है ना? और जैसे आपके घर में आते हैं बाहर से, कड़ी धूप से बाहर से आते हैं घर में, और अंदर आने के बाद आप सबसे पहले क्या करते हैं? दिन में आ रहे हैं, of course. There is a light as well. So you switch on the fan, isn't it? We switch on the fan rotates. So fan rotates at constant speed, right? That's why it is which motion? Uniform circular motion. So the blades of a fan are performing uniform circular motion. The definition is here, right? Right here. You see this? When an object moves in a circular path with a uniform speed, its motion is called uniform circular motion, right? What is a very important condition? When the object moves in a circular path with uniform speed. What is the meaning of this uniform speed? Uniform speed means the speed is not changing. Speed is constant. Are you getting this? Or even if it is changing, it is changing with a constant rate. In an equal interval of time, it is changing. Right? So the change should be constant. You recollect in the previous sessions we discussed uniform and non-uniform, right? Uniform speed, you recollect the definition we discussed, equal distance traveled in equal interval of time. Right? Or basically we can see in other words, change is constant, right? Are you able to recollect? We discussed this in the previous sessions, right? In the first session, distance and displacement, speed and velocity acceleration उसमें discuss किया था हमने, fine. And non-uniform क्या होता है? Unequal distance in equal interval of time or equal distance in unequal interval of time. Simple definitions, right? I told you also during that discussion that I told you to remember these two words, distance and time. So equal distance, equal interval of time, that means uniform. Unequal distance, in equal interval of time, or unequal time, in equal distance, that is non-uniform, right? Already we discussed about it, fine. So that is your UCM, that is non-uniform circular motion. But here we are going to specifically discuss about uniform circular motion. So is the definition clear? Uniform circular motion, मतलब जिसमें आपका स्पीड क्या है? यूनिफॉर्म है, राइट? मतलब कांस्टेंट है, ऐसे ही बोल सकते हैं. Okay, let us go ahead. Now let us take some activity to do, right? You must have done this activity as well. Of course, I have done this in my childhood. Childhood में बहुत मस्ती की हमने, right? माता पिता को बहुत सताया है, right? So here is a one thread, right? And there is a person moves a small stone and is tied to a piece of a thread in a circular path with constant speed by holding the thread at the other end. Okay. So what do? You take a thread. Of course, this is a pen. I'm not telling you to take a pen. This is a thread, let's say. Just imagine it's a thread. And you put a stone at the end of this. And at the other end, you hold this. And you rotate it. Rotate like this. What happens? As soon as you rotate, right? The stone acquires a uniform speed. Right? That means stone is in which motion? Then uniform circular motion. Right? Exactly. Right? So could you tell in which direction the stone will move? Right? When a thread is broken or released by a person. मान लीजिए क्या हो गया? आपने बहुत जोर से घुमाया है इसको. You rotate this so with so high speed that the thread doesn't have sufficient strength to hold the larger speed you are moving it in, right? What happens when thread breaks out? Right, thread breaks out. Then what happens? Then what will be the motion of this or direction of this stone? क्या होगा बताइए? क्या होगा? It will, yes, it will leave its circular path and it will go out of the circular path, isn't it? Right? So to determine the direction in which stone will go, you should try it for the number of times. बहुत बार आपको experiment करना पड़ेगा, right? And maybe at one particular time, at one particular trial, you might be able to find out the exact direction in which the stone will travel when the thread has broken down, right? So the stone will fly off in a straight line tangent to the circle. At every time you see, every trial you see, whenever the stone leaves its circular path, it will leave along the tangent which is drawn at this point. Are you able to see this point? The green color one, right? This is a point. Let's say this point is A, this point is B, right? So this point is A, this point is B. So whenever the stone leaves its path, which path? Circular path, then it will travel along its tangent, right? Tangent के direction में वो बाहर निकलेगा, right? Either you take this point or this point, any point you take on circumference. On the entire circumference, you take any point. At every point, whenever the stone has to leave its path, circular path, it will leave along the direction of tangent at that point. Tangent is always drawn at a particular point. Okay, that is very, very important to understand, right? So tangent is drawn at a point. Okay, so once you join here, iconic Adda. Hello, hello, hi everyone. Welcome. So we are learning the motion parts fifth. Today you joined late, right? Fine. So what I was telling you, at every point the tangent is unique. Because tangent is always drawn at one single point. Tangent is always drawn at one single point, right? So every point tangent can be different. So every point, whenever the stone leaves its uniform circular path, then it has to travel that particular path, right? And every point it will be different, right? So direction is different at every point. As we discussed, circular motion means at every point direction is different and speed is also different, right? For accelerated and for uniform, speed will be same, right? So the question now is why it will always live along tangent path. Yes, hello, Karnav Singh Gujral. Hello, welcome to the Swiflearn. I'm very happy and very glad to see everyone here. Of course, no matter, you joined late. Our session started at 11, no problem. But of course, these sessions are available on our Swiflearn channel. You can please look after them, right? Fine. So we are discussing the uniform circular motion. That's the last part of the motion. Okay. So welcome. So, but why this? Okay, let me revise you for both of you. So this is I'm discussing one example here where you have taken a stone and it is tied to a thread के साथ ज्वाइन किया आपने एक पत्थर और उसको आप घुमा रहे हैं ऐसे, राइट? घुमाने के बाद क्या होगा? The stone will undergo uniform circular motion. Uniform circular motion होगा ऐसे, right? Uniform circular motion होगा. अभी क्वेश्चन क्या है? आपने इसको बहुत तेजी से घुमाया, बहुत तेजी से घुमाया, तो क्या हो रहा है? बहुत तेजी से घुमाएंगे तो क्या होगा? थ्रेड में ज्यादा ताकत नहीं रहेगी, तो थ्रेड विल ब्रेक अवे. थ्रेड जैसे ब्रेक होगा. हेलो, वेलकम रीता रानी साहू. Welcome. So I'm very happy and very grateful to everyone here. Welcome. So I'm discussing this uniform circular motion. You joined late, by the way. Of course, our sessions are available on the Swiflearn channel. You can go through them, right? So I'm discussing on the uniform circular motion, right? Example I'm discussing here is about the stone being rotated in a circular path. तो आपने इसको बहुत जोर से घुमाया तो में ताकत नहीं रहेगी तो क्या होगा? Thread will break away, right? And then what will happen? The stone will come out of its circular motion and it will always come along its tangent path. Why it is so? That's the question. Why it is so? See, the reason is when the stone is released, it continues to move along the direction it has been moving at that instant, isn't it? Let's say take this instant. This instant. There are 4 points we have mentioned here. Let me give some names for these points. Okay. Let's say this point is your A point. Okay. This point is your, let's say B point is your point is your, let's say C point. This point is, let's say, your D point. Are you getting this? One present online. Simple example, right? So there are 4 points A, B, C, D, right? So at A, B, C, and D, the time is different and the direction, position, and everything is different, right? So at A direction is upward, that is towards north. At B direction is towards left. At C direction is downwards, and at D direction is rightward, right? So at every point direction is different, but that direction is along the tangent. Remember now, tangent. What is tangent? Tangent is the line which is drawn at a point on the circumference of the circle. Are you getting this, right? So at A point, the tangent is, this is your tangent. At this A point, this is your tangent. At B point, just a minute, problem here. Fine. At B point, this is your tangent, right? At C point, this is your tangent, as it is shown by arrows. At D point, this is your tangent. So at every point, tangent is different. So A, B, C, D, these are the tangents, right? So every point at that instant, direction is different. That's why it will live along a tangent path. Is that clear? Fine. Anybody has any doubt on the chat session? They can ask. Okay. Is that clear? Okay. Let us go ahead. Now, एक बात तो समझ में आ गई हमें क्या है? जब भी आपका stone, whenever the stone leaves its circular motion, it will leave along its tangent at that particular instant or at that particular point of the circumference of the circle, right? यहाँ तक तो clear है. Now let us continue this discussion ahead. Thus, it implies that the direction of motion of an object moving in a circular motion is changed at every point, right? The direction at every point is different, right? A, B, C, D. At every point, as you see in this diagram, the direction is different at every point on the circumference of the circle, right? So let us discuss now some examples on this topic, right? Uniform circular motion. What are the examples? Motion of the moon around the earth. Have you ever seen the speed of the moon is changed or speed of the earth is changed, right? Have you ever seen, oh, today sun, the day was covered in 23 hours only, or day before yesterday the day was covered in 20 hours only. It never happened till now so far, right? Why? Because always constant, right? That's what the motion of satellites around the earth as well. Satellites rotate around the earth, right, in a circular orbit. Like there are two orbits, geosynchronous orbit and polar synchronous orbit, right? These are the two orbits. And we launch those satellites with the help of GSLV and PSLV, right? Geosynchronous satellite launching vehicle and polar synchronous satellite launching vehicles. These are the launching vehicles of our ISRO, right? So that's the power of India, right? And the third example, motion of a cyclist on a circular track at a constant speed, right? Everyone might be knowing the driving of bicycle, right? So when you drive your bicycle at a constant speed on a circular track, that forms circular motion. Is that clear? Okay. Fine. Let us go ahead with the next slide. Very important topic, centripetal. जैसे आप ये अभी एग्जांपल हमने डिस्कस किया था, ये आप पत्थर ऐसे घुमा रहे हैं, कौन सा फोर्स उसके ऊपर एक्ट करता होगा, right? Some force must be acting, isn't it? And that force is these two pair of forces, centripetal and centrifugal force. Very, very important. Huh? Please give attention fully. So centripetal force. What is centripetal force? It is a center-seeking force that is necessary to keep an object moving in a curved path, right? It always acts towards the center of rotation. Now you can see this, right? You take a ball, like stone, big ball you take, and hold it with the string again, right? So when you hold this and you try to rotate this, like this, when you rotate this, there is a force applied by the ball on your hand. That is what force you call that? That force is called as centripetal force. कौन सा force बोलते हैं उसको? Centripetal force, right? So because of this centripetal force, this ball is able to rotate in a path. And this axis, the person who is standing along that vertical axis, that you can see here as well, that is your axis along which the stone is being, or the ball is being rotated by a person. Is that clear? So centripetal force is right towards the center, right? So centrifugal force, अब इसको balance करने के लिए और एक force होना चाहिए, isn't it? Because Newton's third law, what does Newton's third law say? Every action has equal and opposite reaction. So you are creating an action, creating a stone. Now you are creating action, you have to face the reaction, isn't it? Action reaction pair. So there is a reactive force as well, and that reactive force is which force? Centrifugal force, right? So an apparent force that is felt by an object moving in a curved path, and it always acts away from the center of rotation. So remember, very important thing, centripetal force always acts towards the center of, centrifugal force always acts in the opposite direction of centripetal force, or in other words, I can say it is always acting away from the center of the circle. याद रहेगा बच्चों? क्लियर है? तो ये दो फोर्सेस के कारण क्या होता है, आपका जो बॉल है, या आपने एग्जांपल इसके से स्टोन हम रोटेट करते हैं सर्कुलर पाथ में, so that continues its motion because of the these two forces, and these forces are very, very imagined. We can say they create a magic, right? Magician's forces, we can say. Centripetal, which is acting always toward the center, and centrifugal, which is always acting away from the center, right? Clear है? Fine. Now, अभी इसके ऊपर numericals discuss करेंगे, but not on this. Centripetal and centrifugal के ऊपर formula भी है. Basically, the formula comes of force is equal to mass into acceleration. With that only formula comes, right? So acceleration here we take it as v square by r. आगे जाके पढ़ने वाले हैं यूनिफॉर्म सर्कुलर मोशन, अलग से चैप्टर है आपको, when you go for 10th standard, 11th standard, 12th standard, बहुत डीप स्टडी है इसका, बहुत डिटेल में स्टडी करने वाले हैं हम आगे जाके, राइट. इट्स वेरी इंटरेस्टिंग and very mind blowing concept, right. There are inertial frame, non-inertial frames of references as well, right. Also that we'll be discussing when you go for 11th and 12th standard in science stream, right. It's very interesting topic, okay. But right now for your up to 9th standard, the discussion is still here only, the introduction of centripetal and centrifugal forces. Just keep this in mind, okay. Anybody has any doubts so far, they can write in the chat. If there are some doubts, I can take some doubts. Else, I'll go to the numericals. Okay. So hopefully things are very fine. सबको समझ में आ रहा है, बहुत अच्छी बात है. कोई डाउट्स है तो चैट में लिख सकते हैं आप लोग. चलो न्यूमेरिकल के साथ आगे बढ़ते हैं. Suppose a car is moving. That's the first numerical. Suppose a car is moving. Okay, car is moving on a circular path of radius. How much? 60 meters. With a constant speed. That means it is which motion? Uniform circular motion. If it completes 1 round in 10 seconds, find the speed of the car. Very simple question. Okay, चलो solve करते हैं इसको. Very interesting. Okay, तो given क्या क्या है पहले चीज लिखते हैं. जैसे आपको मैंने बताया. First of all, what you have to write? Given quantities. What is given? First write given. Radius is given as 60 meter. Okay. Time is given as how much? 10 seconds. Right. So car is moving in a circular path. So let's say this is a circular path. Okay. And the car is moving. Let's say this is your car. You're moving in circular path. Right. इसका radius कितना दिया है? 60 meter. और समय कितना दिया है? 10 seconds. So you know what's the formula of speed? Anybody? What's the formula of speed? What do you have to find? Let us write this. To find speed, that is equal to speed के लिए notation क्या लिखेंगे? V लिखा. चलो चलता है. That's a question mark. Solution, right? So solution में क्या लिखेंगे? What's the formula of speed? We know that speed, we have speed is equal to distance divided by time. अभी distance यहाँ पर क्या आएगा? Distance is the distance traveled in circular path, circumference for circumference, right? So speed v is equal to, right, 2 pi r. Exactly, 2 pi r is your circumference of the circle and time t. All the values 2 pi into r. R कितना है? Radius 60. समय कितना है? 10. Sorry, हो गया 6. That comes out to how much it is? 12 pi, right, meter per second. Or you can further simplify this. 12 into 3.14, right? Approximately it should come 12 into 3. 12 3s are 36 approximately. Approx. If you can do this calculation, right? So I'm not taking much time in doing calculations. So roughly it should come 6. That's the answer. Is that clear? Pretty simple question. Speed हमने speed नहीं पूछा था. Speed is equal to distance traveled by time. So distance is circumference of the circle, that is 2 pi r, right? 2 pi r upon time taken as t, right? So 2 pi r, r is given, radius 60 meter, and time we know. Time is how much? 10 seconds, right? So put the values in the formula 2 pi r upon t and do the calculation and get the answer. So simple. Is that clear? Fine. चलो आगे बढ़ते हैं. आओ इसका आंसर भी चेक करना है भाई. नहीं है, हमारा आंसर सही है. Yes, you see this? 2 pi r upon t, that is 2 into 3.14 into 60 by 10, isn't it? Right. So that comes out to be approximately 37.568. If you do the calculations, you'll get this answer. Is that clear? Second question. Suppose a particle is moving in a circular path of radius 6 meter with a constant speed. Again, this is motion. Yes, uniform circular motion. If it completes one revolution in 3 seconds, find the speed of the particle. Now, this is again very simple. Let's solve this. Very simple. एक मिनट, मैंने मार्कर नहीं किया, sorry. It is the color as well. Let me take the blue color one. Fine. Given, because blue is my favorite one. Okay. I hope you must be also liking blue color. Right, radius is given as 6 meter, time is given as 3 seconds. What we are supposed to find out? We are supposed to find out again speed, that is v is equal to question mark. So let us solve. Solution. What's the formula? Sorry. What's the formula? Equal to, right, distance traveled by time. Distance divided by time. Distance कितना होता है सर्कुलर मोशन में? बताइए जल्दी बच्चों. Circular motion, circumference of the circle, how much it is? Yes, 2 pi r. 2 pi r divided by time. So 2 pi r कितना है? 6 divided by time कितना है? 3. Simple calculation. So 3, this is 2. This comes out to be 2 pi into 2, that is 4 pi. This 4 into 3.14. So it should come approximately 12. And do the exact calculation as well, no problem. So this is how you get the answer. 12 pi. No, sorry, 4 pi. That comes out to be 12 approximately. Is that clear? Very simple question. Fine. Let us go ahead. Oh, first of all, let us check the answer of this, whether it is approximately 12. Yes. 12.56 is the exact answer of this question. Okay, 2 pi r upon t. That's what we use the formula. Speed is equal to distance traveled by time taken, right? Distance traveled is 2 pi r upon t. Very simple, right? Let us go. Oh, that's done with these questions. Only 2 questions are there. Fine, no problem. Few more questions also you can do from your textbook as well. So that's my kind request to everyone present in the session today online. Okay, Karnav, Rita Rani, Iconic Adda, please do solve the questions from your textbook as well, right? And if you have any doubts, please do come on this online platform of Swiflearn. We will address your doubts here as well. Okay. Now here is a few questions for you. There are a few questions. First question is define uniform circular motion. Anybody would like to tell on the chat? Uniform circular motion. बताइए बच्चों. Uniform circular motion. Example मैंने बताया आपको fan rotates at a constant speed. Example भी hint भी दिया आपको. चलो. Uniform circular motion मतलब क्या होता है? कौन बताएगा? जल्दी. हमारा सेशन खत्म होने आ रहा है. Right? Uniform circular motion. Anybody? Okay. I don't want to wait anymore because next session has to start on time, right? Uniform circular motion मतलब ऐसा motion जिसमें particle का या object का speed क्या constant होता है, right? That's a uniform circular motion. Give an example of uniform circular motion. As I gave example, fan rotating, isn't it? Okay, we are getting the answer. The motion which move in a circular path. Okay, very good. Okay, who is this? Terminat Gaming. Can you tell me your name, by the way? I hope so. This is not your name. Terminat Gaming. It's name of the gaming as far as I know. Anyways, that's the half correct answer. One more important word you have to add it is at constant speed. वो बहुत important है. Constant speed होगा तभी आपका motion कौन सा होगा? Uniform circular motion होगा. Is that clear? Those who replied. Thank you for your answer. Okay. Example, as we discussed, the fan is rotating at a constant speed. That's what example of uniform circular motion. Another example. Okay, Ayush Trivedi. Thank you for your answer, Ayush. Come for our online session, right? So example बताइए uniform circular motion का फटाफट जल्दी. Example जैसे मैंने बताया fan is rotating. और भी examples हमने discuss किए इस session में. Present Karnav, Rita Rani, Iconic. आप लोग reply नहीं करते हैं बच्चों लोग. I don't like that. I want the answers from you. ताकि टीचर को समझ में आ रहा है ना. Yes बाबा, बच्चे को समझ में आ रहा है. Right? बच्चा पढ़ रहा है. बच्चा आंसर दे पा रहा है तो टीचर को बहुत अच्छा लगता है, isn't it? And at the same time you also feel confident, isn't it? Right? If your answer is right, and of course answer should be right because these are pretty simple questions. ज़्यादा tough नहीं है questions, right? The example, moon rotating about Earth rotating around the sun, or satellites rotating around the Earth. These are the few examples of uniform circular motion, right? Then third question is race on a track. Very good. Thank you, Ayush. That's correct. Very good. Thank you. Name the force that helps the object moving in a curved path. That we discussed two forces basically: centrifugal force and centripetal force, right? So the force which helps an object moving in a curved path is only one, that is centripetal force. Or centripetal force कौन सा force balance करता है? Centrifugal, right? So centripetal is the force which acts always towards the center, that is centripetal force, right? And centrifugal force is that force which always acts away from the center. Okay, fine. So these are the answers, and we are right always, no doubt. Fine. So these are the things we discussed today: uniform circular motion, activity describing uniform circular motion, centripetal and centrifugal force, numericals based on uniform circular motion. So quickly I revise. Uniform circular motion मतलब जिसमें आपका ऑब्जेक्ट का स्पीड क्या होगा? कांस्टेंट होगा. एक्टिविटी हमने डिस्कस किया, राइट? एक्टिविटी कौन सा एक्टिविटी? यू टेक अ थ्रेड एंड पुट अ स्टोन अगेंस्ट इट, यू रोटेट इट. वो एक्टिविटी हमने डिस्कस किया, राइट? एंड सेंट्रीफ्यूगल में एग्जांपल कौन सा डिस्कस किया हमने? लेट्स से यू हैव अ बॉल कनेक्टेड विद द स्ट्रिंग, अ हेवी बॉल, एंड यू आर रोटेटिंग. तो रोटेट करते समय बॉल के ऊपर कौन सा फोर्स एक्ट करता है? It is acted upon by centripetal force, which acts on the center, right? Where from the center, उसी line of action के along कौन सा force act करता है? Centrifugal force. And then we discuss two numericals for calculation of speed, right? Speed is distance traveled along the circular path, and that 2πr upon time. So distance upon time. Distance traveled upon time is a formula for speed. Okay. Thank you so much for everyone for joining us today. Thank you. And please don't forget to subscribe to our channel, and please don't forget to press on the bell icon so that you don't miss any of our updates. So meeting you again in the next session and the fascinating topic with this fascinating topic of science. So we have ended here today topic. So if you are more interested about my sessions, please do like our videos, especially mine, right? Motion videos. And please spread a word with your friends, right? In the home, right? Live sessions on the Swiflearn. Okay. So see you again with the new topic in the upcoming days. Okay. Thank you. All the best. Bye bye. Take care. Thank you. All the best.